Hello everyone, welcome to the second episode of the Data Show. And this time around, we have a very esteemed guest on our show. With over 3 decades of experience in data science and predictive analytics, he is none other than Dean Abbott, who is the co founder and chief data scientist of one of the leading marketing platforms called SmarterHQ. Now, SmarterHQ is a behavioral marketing platform that makes it easy for marketers to increase revenue and build better customer relationships by powering highly personalized and cross channel experiences. Now, the platform is trusted by leading brands like Hilton, Santander Bank, Bloomingdale's, and many more. Now, Mr. Abbott is an internationally recognized data scientist and predictive analytics expert who is also the author of the book Applied Predictive Analytics. Now, Mr. Abbott has been applying advanced machine learning algorithms in fields like risk modeling, fraud detection, customer analytics, personality assessment, and many more. So, how has he been able to do so much in his career? Let's learn from the man himself. Well, hello, Dean. Thanks for taking out your time today to meet. I'm really excited to have you here to talk about the rise of applied data science and predictive analytics, and especially how Smarter HQ is advancing in this direction. So it would be an enriching experience for all the data professionals as well as aspirants who basically, if you could even get a glimpse of what you have experienced in the field of data science with over 3 decades of experience, that would be great. So to start off with, and before we discuss all of those deep questions about predictive analytics and how Smarter HQ is incorporating data science, I'd like to ask you this very fundamental question, as there are a lot of notions around it. So how do you unpack the term data science?
First of all, thanks for setting this up to talk. I mean, we've had some interesting discussions in the past, and this is just like an extension of our conversations before as well. And it's I feel like in some ways having these kind of conversations for me are it's almost cathartic because I feel like in my career I'm such an ordinary just analytics guy. I mean, I was just doing the work, and I lasted a long time. You know, Woody Allen once said, 80% of life is showing up, and I just feel like I've shown up for a long time, and data science is one of those things that's kind of evolved over the years in terms of how it's defined. Because when I started in the late '80s, of course, data science wasn't a term. So, data science for me, for the most part, is really the same kind of analysis that a lot of more on the computer science and mathematics side of the community has been doing for decades. You know, machine learning and statistical learning, pattern recognition, and
Yeah.
it's kind of grown through all these different phases over the years. I mean, when I started my career, as more doing things like neural networks and other kinds of statistical learning, and then doing the data mining and predictive analytics phases when those were the key, those are the labels that people used. But there are a couple of things that are different about
Hmm.
data science, in addition
Yeah.
to just using a lot of machine learning tools and try to automate as much of the processing as you can. But some of those differences are data science seems to be at its core revolving around programming languages like R, Python, SQL in particular, those three languages
Yeah.
that seem like it's inherent to the community or necessary to
Hmm.
be a data scientist. You need to know one of these languages, which is fine, but it's different than like data mining eventually evolved into the state where people were using a lot of GUIs to do the
Yeah.
analyses. So
Yeah.
that's one difference. Another difference is data science, I think in part because of the time that it's ascended,
Hmm.
is very cloud infrastructure focused. So
Yeah.
there is a lot of emphasis for how to scale, how to create
Data
efficient
engineering.
processes, how to automate it. You know,
Yeah. So you're talking
so
the
like
data engineering part of it.
Yes, the data engineering part, and even from a computational part, whether
Yeah.
it's like in like MapReduce and Hadoop
Yeah.
was very core to what a lot of data scientists do. So, I mean, some of those things are different, but that's not, to me, that's not fundamentally what differentiates data science from other fields of analytics like
Hmm.
statistics and more the BI way of doing analyses. And that's more the machine learning flavor. But it does have, it's because you end up creating the data science unicorn. You've probably seen like those Venn diagrams about, what is the
Yeah.
ideal data scientist? They've got to
Yeah.
be programmers, and to hack, and they've got to be domain experts,
Yeah.
and they've got to have, all these things.
Statistics background, mathematical background, and all those things. Yeah.
Yes, and it's like there's almost nobody out there like that. I mean, it's such a high bar,
Ha-
but that's really
Exactly.
where the field is going toward, those three
Yep.
areas.
Well, great. I totally agree with your definition, and it's quite nuanced, and there are a lot of notions around it. So, and it also depends on the kind of structure that you are in, the environment, and also the kind of problems that you're solving. That also defines the kind of data scientist that you want to become or that you are. So.
Yeah.
So let's get into Smarter HQ. So I read an interesting story about how Smarter HQ came into this picture. So with a marketer and a data scientist who were sitting, and they wrote down their idea on the back of a napkin. And so what was that story? What was that idea that laid the foundation of the company, Smarter HQ? Yeah.
It's really true. Because the other co-founder, and I'd say the co-founder with the capital F, because it was really his brainchild. And I was
Uh-huh.
like the smaller case F co-founder. But Angel and I met at a conference in San Francisco in 2008, I think.
Uh-huh.
And we were at this conference as a pre-conference event. I was invited to go up there by the conference organizer, and it was a bunch of roundtable discussions on a bunch of different verticals. I remember there was a guy from Expedia who was there, and they're different, talking about how they apply advanced analytics in these fields. So, and we're around these literally round tables and having
Mhm.
discussions, Q&A, just interchanges. And this one guy, Angel, was bringing up some really interesting things, and I was responding to him. And so through a lot of the day, we're sitting at the same table, kind of hit it off. And then after the meetings were over, like 5 o'clock, we went to the bar just to say, hey, let's keep talking. So we're there having a drink, talking through some things. And he was writing out some ideas that he had about retail analytics and email marketing, and how predictive analytics, which was kind of the sexy term of the day, could be applied
Yeah.
to email marketing. You get more data, you build some models that tell you interesting stories. And so we're going back and forth. And he drew on his napkin just kind of a depiction of the kind of data that he wanted to collect. So I was looking at
Mhm.
that, trying to figure out what kind of models I'd build around that. And it was so interesting that I canceled my flight. And I stayed there. We kept talking and talking. And that
Oh.
was really what launched the company, because we stayed in touch. I remember weeks later talking to my wife about this, and she'd say, who is this guy? I mean, what, you're going to start a company with this guy? Do you know anything about him? Like, I don't know much about him, but it's such a great idea. I'm sure we can make this work. So that's how it started. And one of the things I'd like to
Interesting.
say about data
Yeah.
science is
Yeah.
I talk often about the three-legged stool of successful analytics, where you need kind of the domain expert, and that was Angel in email
Mhm.
marketing, and
Oh.
the analytics guy, which is me,
Mhm.
and more of an IT data infrastructure guy. That was our first hire, who was
Oh.
the data infrastructure guy. And we came out to La Jolla, where my office was, and we built our first models, built our data model. It was really fascinating to see it all unfold.
Great. Really sounds fascinating how it turned out to be such a great company. So I know as a founder, you must be having a lot of hats to wear, but I want to know, like, what are your responsibilities as the chief data scientist of the organization? And also, how would you describe a regular day at Smarter HQ for a data scientist?
Yeah, and like you say, with smaller companies, you wear a lot of hats. And in the early
Yeah.
days, I was doing like almost everything in some way, shape, or form on the, especially on the programming side is and the data science side, building models, doing all the data prep and doing the building, how to deploy the models, all that kind of stuff. Um, More recently, my
Hmm.
focus, there's always been an emphasis on my role of the company as a co-founder, just being a, like the face of the company and being a leader. So outward
Yeah.
communications to the industry.
Hmm.
So when I do talks and workshops and even if I'm not telling the data, the SmarterHQ story, but to
Yeah.
be representative of this is the way SmarterHQ thinks about data. Uh, but then on a more day-to-day basis, we have models in the platform. We're always thinking of new ways to either report on those models or build new models. So I'm working very closely, especially with our client success team, to
Uh-huh.
understand how our customers are using the data and building out their campaigns, what kind of insights they'd like to have. And then I'll build report prototypes or new model prototypes for them to look at, can show them what they look like. And then if they look promising enough, then I work with our engineering team to work through
Okay.
how we can actually implement these. So I work with a lot of different teams. Sometimes I'm on sales calls, especially if there's a more high profile client who wants to know more deeply what's
Hmm.
going on with the company, or if they've got data scientists they want to bring on and say, okay, what do you actually do? Explain to us your model, so I can jump on
Yeah.
those calls as well. I
Okay.
never know. I mean, each week can be really different. Some days I'm deep in the weeds with data. Some weeks, like last week, I was more on sales calls. You just really don't know.
Okay. So, and how would you describe it for, a junior data scientist, a data analyst who's working at the company?
Yeah, and so for the more junior ones, and we typically hire in at a higher level, not a real junior guy, but
Okay.
more senior level, because I really need them to be autonomous and do a lot.
Yeah.
I want them to do a lot themselves, especially for the uh,
Hmm.
first few hires. But a lot of what they've done is taken the ideas and turn them into reality. So one example is um, we were I was thinking through how to build a product recommendation engine for our platform to do more algorithmic based product recommendations. So you
Hmm.
come to the website, you're browsing these products, which products should be recommended that are most likely to convert or most likely products you would browse, kind of like the Amazon lookalike models.
Uh-huh.
And so I explained it to the data scientist. We talked about ideas and then handed off to him and he implemented it. So he did it mostly in SQL and for this particular case. But
Oh.
so he needs to know enough about how the algorithm worked to do it
Hmm.
right. And then
Hmm.
I could talk to him at a higher level and not like walk him through every step along the way. And it was fun for him because I mean he pretty much knew what to do. I was really
Hmm.
kind of guiding the high level picture to make sure that we were connecting up with what the business wanted. Uh,
Okay.
but he had full autonomy to build it however he wanted to build it. And then I do peer reviews and things like that, of course.
Okay. So you were basically just directing him, as in like,
Yes.
okay, great. So nowadays, you should see almost every other organization claims to use machine learning to add some sort of, customization, that magic of personalization to their applications, but not many have been successful. So how does, SmarterHQ incorporate ML that sets you apart from your competitors?
Yeah, it's an interesting question because in the early days of the company, nobody understood predictive analytics and machine learning.
Yeah,
Like we
yeah,
would tell this
exactly.
story to marketers and they'd just be kind of looking at us with blank stares. And so we had to do a lot of explanation about what we did, why we do it, and why a data-driven approach to finding insights automatically
Hmm.
was so valuable. And a lot of the marketers had a hard time. They felt like they're giving up some of their autonomy. Like, why do I need a machine to tell me things? I mean, I've been in the field for 20 years. I know what the customer wants. And I was saying, well, yes, that's true, but you don't know everything, And so, uh, context the core of what we do and why our machine learning is so successful, I put on two pieces to it. Piece number one is the data model. So
Okay.
to collect data in a form that's accessible at a granular level, And so when Angel and I had our first meeting, I mentioned the three-legged stool, and when
Yeah.
the first meeting in La Jolla with Angel, Chad, who is the SQL guy and the infrastructure guy, developer, and me, we argued, especially Angel and me, we argued for days over what the data model should look like. You know, what table should we build? What should be in the columns of those table? What should a row represent? When we build predictive models like a purchase propensity model, what is a row in that model? What are we trying to predict? Are we trying to predict just with at the customer level what a customer is going to do? And
Mhm.
where we landed is at the customer day level. On a particular day, what do we expect that customer to do in the end days subsequent to that particular day timestamp? Which means you build the data differently than it
Okay.
was if every record was just a customer. And we did that deliberately so that we could get model scores going back in time and forward in time at our will, and we
Mhm.
aren't tied to a fixed timestamp. With that, the customer level would be as of one point in time. We wanted to have the model applied at a number of points in time that we could control. So that data model is critical. The other part that is important with that is automating all the processes we do so that we can apply. We're a SaaS company, software as a
Yeah.
service.
Yeah.
And so to apply the model building infrastructure in a way that we can apply to all of our clients without me having
Yeah.
to tune every model. So it took probably about 2 years to fully build out the automation for the scripting across all
Mhm.
our clients to build models, have them assessed and deployed automatically. So those two things were a little bit different. One of the things I noticed along the way is a lot of our competitors were telling a very similar story, but it's on
Mhm.
that data side, the data model side. That's where when you get deep into the weeds, you start seeing the kinds of data that we had available that they didn't. And just at a very simplest, most simplistic level,
Mhm.
a lot of our competitors were building purchase propensity models based upon historic transactions only,
Oh.
not historic transactions and visits. Like, so a visit is an interesting event. In fact,
Okay.
a shopper who visits once and does something on the website is still important information to differentiate that kind of behavior in the session with behavior of shoppers who do come back and purchase something. So visit behavior along with transactional behavior was really important with our models, and it continues to be. So things like that are just, I mean, when you're telling the story in the marketing gloss, those things
Mhm.
get lost. But then when
Yeah.
you start drilling down to see what people really do, those kinds of fundamental differences really begin to emerge.
So yeah, so it's all about the fundamental differences, and of course how you have come up with the data model for your data collection process, and the
Yes.
setting the granularity and the kind of data that you want to collect, as you mentioned, customer day. So yeah,
Yep.
great. So now my next question would be, apart from your role as the chief data scientist, you give regular talks and workshops. So what's your motivation there? Like what are these talks like? So if any of our aspirants or viewers want to see Dean give a talk, how can they interact with you, or maybe enroll for a course or a workshop that you're giving?
Mhm. I think one of the reasons I do these talks is I love the field. I think it's
Mhm.
like the funnest job anybody could have. And
Couldn't
it's
agree more.
and when I was starting out in my career, those first 5 years, my first position at a small company in Virginia called Barron Associates. It was an
Uh-huh.
aerospace engineering company. I was doing missile guidance and sonar and things like that. It was a lot of fun stuff.
Rocket
But
science.
yes, exactly.
Exactly.
It really, it was rocket. When you say it's not rocket science, well, this really was rocket science. And the being able to learn from people more seasoned in the field, as for me as a young, I was like 23 years old when I was starting there, and
Yeah.
it was so valuable to have that interaction. And the son of the boss who went on to become a dual position professor at Yale in computer science and statistics,
Mhm.
either that or engineering, double E in statistics. I forget which, but statistics was one of them. being able to have those side conversations and pick his brain, or just have, most of them was like, just tell me something. Like anything you say is interesting. Just tell me something about what you're thinking about. And it was like a sponge absorbing all this information from others. So I think there's such value, especially for young data scientists, such value for them to hear the stories from the trenches, hopefully told in a compelling way, but hear the stories from the trenches so that they can be encouraged,
Mhm.
know that nobody knows all the answers, but at the same time, trying to connect up some of the stories they're hearing to what they're experiencing in their job to kind of pull these different tips and tricks
Yeah,
to keep in their arsenal so they can pull them out when they need them. So
exactly.
when I'm
Yeah.
giving talks, that's one of the things I'm trying to think through is most of these are really smart business professionals, or they're new to the field. They're trying to figure out how to do this. How can I make this more exciting, more accessible, more understandable so that they can go back and do their job better? Uh, so the most frequent places I speak at Predictive Analytics World every year. They have a conference
Okay.
in Las Vegas in June and in Berlin, Germany in November. And so I'm hoping that the Berlin one will still be taking place in person. But I get to go there every year, which is, I just love going to Berlin.
Amazing.
I do a lot of teaching workshops through TDWI,
Okay.
which is historically it was a database organization. Used to be called the Data Warehouse Institute, but now it's transforming data with intelligence is their new
Okay.
branding, and they've become much more data science centric. So I teach a data science boot camp with them,
Okay.
uh, and then I'm usually speaking at an event every month, at least before COVID, and it's a lot. I've spoken at financial conferences, at healthcare conferences, at local meetups. Basically any place, if I've got time in my schedule, and I keep some time in my schedule just for these kinds of things because
Hmm.
I do find them valuable. I spoke at the Illinois Institute of Technology to their students last year, which was really fun to meet a lot of students and see
Exactly. Yeah.
how passionate they were about learning data science. It was super cool. So probably my biggest reason for doing this, like I said, is to try to unpack some of the complexities of data science in a language that they can understand. A lot of use cases, but not a lot of heavy math, but explaining what the math does. Like you don't need to know how to
Yeah.
invert matrices to use regression well, but you need to know what uh, squared error does
Yeah.
to distributions when you've got outliers or skewed or even got high kurtosis, what it
Yeah.
does to the regression model in order to diagnose problems and improve your models. So that's
Exactly.
what I try to explain.
Great, great. I see that you are an author for the book Applied Predictive Analytics with Wiley, and I plan to read it soon. So, would you mind talking about like who that book is for, and how can it help an aspiring data scientist?
Yeah, the book is for business professionals, and they
Okay.
don't have to have a background in math per se. Though what helps
Hmm.
is number one, I'm assuming you know something about data.
Okay.
So you've loaded data in a spreadsheet and poked at it before.
Yeah.
Uh, some basic statistics is helpful.
Hmm.
What does a mean? What is a standard deviation? I mean, I go through
Yeah.
explaining
Hmm.
more details about those, but I don't go into foundational things. I don't discuss the central limit theorem. I don't talk about cumulative distributions, things like that.
Yeah.
So
Yeah.
it's helpful if you know a little something about things like that. But mostly it's people who just love poking at data to try to put some structure behind how to go about using these machine learning style techniques, advanced analytics techniques to analyze that data. So I use as the foundation for the book CRISP-DM, the cross industry standard process model for data mining,
Okay.
6 stages of the process, and the different chapters of the book are really addressing those different steps.
Hmm.
So that was the core reason for it. And Wiley, their editor asked me to do it, and I said no for a long time because I didn't want to write a book. It just takes
Yeah.
too much time. But they
Yeah.
finally convinced me to do it, in part to take all the lectures I was doing anyway, to just
Hmm.
turn those into a narrative, put that into a book form. I was like, okay,
Yeah.
I can do that.
Exactly, and it turned out great, and yeah, there's not much on predictive analytics, and especially the topics that you just mentioned for business professionals.
Mhm.
So great, and I see that there's a lot of conversations and debates going on about the importance of degrees in data science. That you need to have a degree or a PhD at least to get a job as a data scientist at a big firm or a mid-sized company. So with education being redefined today, so how much do you think does a degree or a doctorate contribute to an individual's success in this field?
Mhm. Yeah, this is controversial, and I'm
Yeah.
on definitely on one side of this debate, and a lot of my friends and colleagues are on a different side of this one. So I, for me, I really don't care what your degree is in.
Hmm.
Um, I've worked with data scientists now, or help train them who don't like have a marketing degree, or maybe a history degree, or maybe like accounting. So they're used to using math, but they're not used to using machine learning. They don't think algorithmically necessarily.
Yeah.
But the key to me, the real foundational thing is with this style of analysis, and I'm not talking about the statisticians have a very specific way they look at data.
Yeah.
And machine learning professionals, data scientists, have a different way of looking at data. So, and that way of looking at data, because it's data driven and the data we're looking at is so noisy, you have to be like a data sleuth, like
Yeah.
data forensics.
Yeah.
You have to notice, you have to be, I think you need to be very particular about your data and notice any problems with your data to be very successful. So, the people that I've had the most success in working with and training and speaking with years later are people
Hmm.
who just love data. They love poking at data. They notice things in data. Even if they don't understand the math, they can pick that up over time. Uh, so do you need an advanced degree? I don't think so, unless you're doing something really leading edge. I mean, there's some fields where you are forging new ground.
Yeah.
You're building new algorithms. You're not just using something off the shelf like a standard decision tree or naive Bayes or support vector machine or neural network or whatever you use. If you're really um, doing cutting edge research, then at
Hmm.
least a master's degree is really helpful, just to have additional experience at a more theoretical level, understanding what the capacity for the different algorithmic approaches are. And let me give you one simple example that helped me in my career. So I was a computational math undergrad, so I understood algorithms, I understood computational complexity.
Yeah.
In grad school, I was in control theory and I did a lot of optimal control. So I understood better optimization methods, which optimization methods are not in the core of data science. But there's a way that optimization algorithms work that helped me and continues to help me on the data science side as I'm trying to build new kinds of models and really forge new ground, because there's the idea of a multidimensional cost function that you're trying to minimize with constraints. Those
Yeah.
kinds of ideas are not core to like minimizing squared error or Gini or entropy, those kinds of
Yeah.
metrics that are used in machine learning kinds of algorithms. So it is helpful to have a broader background when you're forging and like hacking away through the forest with new kinds of algorithms. So in those situations, certainly a master's degree. The advantage of a PhD over master's obviously is you've done a dissertation. So you've done a
Hmm.
super deep dive in a very narrow area, and you've
Yeah.
had to define it. It's like a project you go start to finish. And that's valuable in of itself, regardless of what your topic is. Even if you never use that topic again, going through that
Yeah.
process can be very advantageous. So, especially to be a lead with a company going through like forging new ground, that PhD can really be valuable as well. But I'd say the vast majority of data scientists that are out there, the vast majority of work that's done
Yeah.
across organizations, the tens of thousands, hundreds of thousands of data scientists, you don't need an advanced degree. You just need good core principles to apply.
Yeah, and I really like the fact that you mentioned people who really like to, poke around data. So it's kind of like that curiosity and that inquisitiveness that actually required, to drive these people and find those hidden patterns inside the data, and
Yeah.
come up with really great models.
Yeah,
Great.
it's interesting because there's one guy I worked with years ago that was really picking up the concepts well. Where we built a model together, we finished it, and everything looked good. So then we
Yeah.
got some more data and we started another process, but he wanted to go through the exact same steps we did the first time. He's very recipe driven. And I said, no,
Ah.
no, no. We don't know what this data is going to bring us. So we have to start from scratch. And for some people, they really want that script. And that's this is new models are hard for them. For those
Yeah.
individuals, it's better for them to maintain, update the models. They can still be good data scientists, but they won't
Mhm.
be building the first model. They'll be updating the models, improving them later. And because they just don't, it's hard for them to think in terms of uncertainty in that way. Every data set's
Mhm.
different.
Yeah. Yeah. So you started off your career, with a BS in computer computation, mathematics, and then you followed by masters in applied mathematics. So, and this was way back in 1985. So
Yeah.
I like to know, the career plans that required you to be, a mathematical pro, mathematics pro, and now at this point, to what degree has your mathematical aptitude helped you out, in your career, and what's your take on actually learning mathematics for data science? How, as so you mentioned that you should actually be aware of the kind of effects that your approach is going to have on your model, but
Mhm.
if you could just give us a little more detail on how learning mathematics would help you out, and what kind of mathematics should one
Mhm.
learn.
Yeah, when I started undergraduate in 1981,
Yeah.
I was in math just because I liked math in high school. I had no idea where it's going. Some people have that like 10-year plan, 15-year plan. I was
Yeah.
not one of those guys. I just knew I like math. I'll take math. I've heard that computer programming, computers are getting big. I should do some computer programming as well. So I did the computational math major,
Yeah.
uh, which was very useful. Almost every upper division course I took, I used in my
Hmm.
career at some point, whether it's because I took courses in ordinary differential equations, partial differential equations, differential geometry, and I used them all in one way, shape, or form. Um, but when I finished my undergraduate degree, I felt like I didn't really know a lot. I went into my interviews with like IBM and MITRE, and I had 4 interviews. And I left those interviews thinking, there's nothing I can really offer them. I mean, I can't solve any problems for them. I know
Okay.
broad principles, but I don't really know exactly what to do. So that's why I went to grad school to learn more.
Okay.
The thing that was valuable, the reason why mathematics was a good foundational a science to bring to bear is, especially computational math and data
Yeah.
analysis, understanding how algorithms work was really helpful, especially from a teaching standpoint. So on one side, just from being able to build new cutting edge algorithms was helpful. My
Yeah.
first job, I was doing simulation, and I had to really think about integration methods like
Hmm.
Adams-Bashford methods and truncation error and how quickly they converge so that we could
Okay.
build these simulations well. So all that stuff was tremendously valuable. But I also took a lot of courses in engineering, doubly, which helped
Hmm.
me think through how to apply things. When I was looking for a topic for my thesis, I went to the engineering department after the recommendation of my applied math professor to
Hmm.
look at he wanted me to look at equations with periodic coefficients, systems of equations with periodic coefficients. I went to the double E department and asked them, is this useful for anything? Is this useful? And everyone said, no, no, it's not useful. So I didn't do that because from a mathematics standpoint, it'll be interesting, but I was always more wired toward what could I apply and do well from that standpoint. So trying to add techniques to my tool belt that could help me understand how to analyze data. That was the real benefit of mathematics. What the benefit now for me, in addition to, if I'm doing something that's relatively cutting edge, it's explaining the techniques to other people and getting at where will a decision tree fail, where
Mm-hmm.
will regression fail, what are the problems neural networks have with convergence, why do they have those problems, and what can you do about it. I think the mathematics background helps to uncover those kinds of issues. Now, you can understand how to apply it and turn the right knobs without knowing the
Yeah.
math, but somebody's going to interpret it for you. And
Yeah.
that's one of the roles I wanted to take on, is say, okay, this is what the math is. You don't need to worry about that, but this is what it does. And this is why you need to care.
Yeah. And it does make sense. I mean, if you get into a situation where you're not aware of how your data is actually interacting with your model, it's just you're just simply turning their knobs on a radio
Yes.
system is
Yes.
trying to figure out if something is gonna simply just stick, and I'll start listening to songs. So those are the kind of predictions that you'll be making. So
Yep.
yeah. So what qualities, so you're hiring a lot, and I want to know, like, what qualities do you look for in a candidate appearing for the position of a data scientist at your company?
They get there. We've already covered some of that. At the core, I'm
Yeah,
looking for somebody
exactly.
who thinks about data in a creative way. I remember I worked for a telco company years ago,
Hmm.
and I did some consulting firm for a year, but then I was kind of expensive, and they wanted to keep doing the work, but they wanted to hire junior data scientists to
Okay.
do that work. So they asked me to help them hire. And I
Uh-huh.
thought, okay, that's fine. So I developed a test for the new hire
Okay.
candidate screening, and it was an analysis that they had to do, and with
Okay.
the data set that I picked. And
Okay.
so they had to take a day or something to do the
Hmm.
analysis. The What they didn't know is when they reported back to me and what the analysis was, I really didn't care how good their solution was.
Okay.
What I wanted to know was, given the time constraints, they really only had a day or so to do an
Yeah.
analysis.
Yeah.
What things did they decide to do and why? Like, what data prep steps did they do about? Why did they do those? Did they
Hmm.
think about what the business objective was? What was I explaining that they needed to do from in the language of the business? How are
Yeah.
they tuning the analysis to try to answer that particular question? Or did they just have their techniques they want to use and they'll try to fit the
Yeah.
business use
Everything they
case
know.
to
Yeah.
their process? So it's things like that. And what I was really looking for is someone who was able to make the good decisions along the way,
Hmm.
and with some explanation to get to an answer. So they had an answer. They didn't get stuck and say, I tried hard, but I just couldn't get to an answer. I ran out of time. Because in the business world, there's no such thing as running out of time. I mean,
Yeah.
you have to get it done.
Exactly.
If it's
Yes.
supposed to be done tomorrow, you do the best you can to get maximum value by tomorrow, and do you deliver that? So I was looking for those kinds of things. So the things that I'm looking for are good critical thinking skills,
Hmm.
ability to differentiate competing techniques,
Okay.
competing approaches, and be able to trade them off and land in a reasonable place. It doesn't have to be the best place, but land in a reasonable place so that you ultimately deliver a solution on time that provides some
Uh,
value to the business. So that's why I want to see that thought process, which means you've got to deal with uncertainty. You've got to deal with an imperfect situation. You got to deal with bad data. There's a lot of things you've got to deal with. And at least that's what I'm looking for, especially when you have a small team of data scientists
yeah.
and you can't have people that have very specific, strong skill sets that are limited. You need
Hmm.
somebody who's more of a generalist. If you're just
Yeah.
hiring for a bigger team, you can be very focused and hire that data engineer who's just great in Python and
Hmm.
SQL and can do all this data munging, and they love working in that world. They
Yeah.
understand enough about data science and the algorithms that they know what you're looking for, but they just love munging data. Like,
Yeah.
great, we can get someone like that. Or another person who's just great at building models, but they get bored with the data prep stuff. I mean, if you can afford that, you can focus. But if
Yeah.
you've got a small team, you really need more of a generalist.
Yeah. Kind of like the term or the new term that's coming up, like the full stack data scientist, the generalist who can actually go about collecting data, creating data infrastructure, and then developing models as well. Uh,
Mhm.
yeah, great. So I think this is what a lot of different companies have been looking for. I read a few interviews, and there's Chris Albin who also talked about, they also look for generalists in their firm so that they can, because it's always when it's a small team of data scientists working together. So they need people who can actually be autonomous and take care of
Yes.
their entire projects. And you need all those kind of skills and people to come from to have broader background. So great. So the next segment is basically the rapid fire round, where I'll be throwing questions, very really short questions, and you just have to reply in like 2 or 3 seconds. So
Okay.
all right, let's do this. So first of all, R or Python?
If I had to choose one, it'd be Python, but R is great and SQL should be in the list too.
Okay, okay. So R or Python or SQL, then
Python,
Python.
number
Okay,
one.
okay. Given a chance to change the field of your work, which another field would you like to solve the problems of?
That is so hard, but I'll tell you the weird one is archaeology.
Uh, great. What would you want to do there?
So to try to piece together the findings and the
Uh-huh.
characteristics of the findings, to try to date them and put them in the historic context. And you could use some analytics methods to try to help you in that process.
Okay.
In words, natural language processing is a
You
big
are
part
a
of
true data scientist then. You are a true data scientist. So a recent book that you have enjoyed reading.
it. I'll mention one, the Washington Life by Chernow, the biography of Washington. I love reading
Okay.
biographies
Okay.
because they tell you a lot about how people think and how they make decisions.
Uh-huh. Great. So next up is, what sources do you use to stay informed of the new technologies, libraries that keep coming up in the field?
The places I go to are first colleagues.
Uh-huh.
And just this last week, the two colleagues that gave me information I just love, James Taylor and Keith McCormick.
Okay. Okay.
James Taylor's got an article, I'll pass this along to you, on data scientists think data is their number one problem. Here's why they're wrong. And
Okay.
fascinating article about decision making. And Keith McCormick passed along a lecture by Judea Pearl, who talks about causal modeling.
Okay.
Fascinating stuff. Causal modeling and AI. So
Oh,
that's the first
interesting.
place. So colleagues that I read on Twitter or LinkedIn. But
Yeah.
in terms of text and all, I go to medium.com a lot now. Their towards data science and their machine learning
Yeah.
pages are really quite good. And I'll
Yeah.
disagree sometimes, but I like the content very much. So I'd say those, and then other broad websites like Data Science Central and Katie Nuggets I go to a lot.
Yeah. Yeah. Those are two great sources of data science topics. All right. So given a chance to hang out with one famous personality, with whom would you like to spend an evening?
You know, when I saw this question, it's really hard because there's so many people to be interesting, whether they're famous or not.
Yeah.
Where I landed, and this is back to that history theme, is Paul Johnson, who was a historian from the UK, who's like 92 years old.
Okay.
And I would, here's because I love history, especially like the reason I said is, why do people make the decisions they make? Like I read Malcolm Gladwell's book Blank,
Yeah.
thinking in terms of data science, like how can you take these principles about how people make decisions and turn it into features? And so I
Yeah.
want to know, how do people make decisions? What is their cost function
Mhm.
that they're trading, to put in mathematical terms, when they're trading off? How do they trade off these multidimensional complex systems and land somewhere, especially the ones that are successful? And so Paul Johnson's a historian. I've read a lot of his stuff. So he was the first one that
Okay.
came to mind.
Great. So, how many hours do you usually work in a day?
I mean, it depends on what you mean by work, but like with my main job, I mean, it's like
Yeah.
8 to 10 hours for the most part, but then there's teaching and lectures and other things outside of that. And
Okay.
for me, it's gone up and down. I mean, there are periods of time where I was more of a 12-hour a day
Uh-huh.
guy, probably like 60 to 70 hours a week. But
Okay.
then there are other times when it's been lighter. I mean, I think it's hard for me personally with life balance and all. It's hard
Yeah,
to
yeah,
maintain that kind of schedule because I would work during the day, come home for dinner with the family, and then
yeah.
get back in the office from like 9 p.m. until like 1 or 2 in the morning, and just kind of do
Uh-huh.
that every day. And that's a hard thing
Interesting.
to do for
Yeah,
years.
yeah, yeah. I totally agree. So how do you decompress yourself?
Uh, Doing stuff with my wife is always enjoyable. Just
Uh-huh.
hanging out, talking with her, and we do things like wine tasting together, which is a lot of fun. And
Yeah.
when we go traveling together, I mean Europe or a place like that, we just love history. I've got 3 kids who are all adults now, spending time with them. Um, I'm very involved with my church and doing things with my
Great.
church friends and all. And then at
Okay.
home, I think it's important, at least for me, to do home projects. Like I mow my own lawn, I do my own yard work. From that standpoint, I think it's
Oh,
good to be
nice.
connected with something that is not so cognitive, and it's just
Yeah.
beautiful, just to do something that is kind of
Staying
almost
connected with
mundane.
nature. Yeah. Yeah,
Yeah,
yeah, yeah.
and so I'll build things, and I've built decks. I've built, installed cabinets and built cabinets from my garage and do things like that. Just because I think it's
That is
again,
so
I'm not very
cool.
handy either, but it's useful. I think it's also very humbling to do
And
that.
there's something I should take away. I mean, like my mom keeps complaining that you don't do anything. So you have to keep calling some guy for this, your electricity stuff, and you're a carpenter for all of this. I should definitely learn this thing from you. Yeah.
Yeah, I
So,
really don't like doing electricity. I've been shocked too many times. I've rewired ranges where like 3 will work at a time out of the 4 burners because I did something wrong. Don't know exactly what it was. It was random which 3 would work, but there'd always be 3 that work. So, uh, yeah, it's humbling, but it is a good thing to do.
yeah. So one last question for our viewers. Do you have any message for the aspiring data analysts or scientists or any data professional in general? One last message for them to take away from
Yeah,
this conversation. Yeah.
this field is so much fun because you can apply the same principles and techniques so broadly. So,
Yeah.
you know, learn the basics, apply it. That's the best way to learn. I think is just keep trying to apply it, and I always like thinking in terms of the next model I'm going to build. So you're building a model. Think through like the 5 or 6 things you wish you could do if you had time. Store them away. Then the next project work, maybe one of them you can incorporate and learn from it, even if it doesn't get deployed. Then maybe 2 or 3 projects down the road, you're starting to add these new ideas. So always get more information, more techniques, talk to your colleagues, read. That's one thing I asked a colleague at the very beginning. How do you stay up in the field? He said, read voraciously. So now
Yeah.
we've got YouTube, so you can do it in different forms because some people are better auditory learners or
Yeah.
visual learners, and some people are better with reading. But there's lots of content out there.
Exactly. Yeah, there's lots and lots of content out there as we are producing as well. So great. Thank you so much for having this conversation. I'm sure the viewers would have a lot to take away from this enriching conversation. And yep, thanks for your time, Dean. Really means a lot.
Thanks. I really enjoy doing it. Anytime we could do this again. It's a lot of fun. You're a great interviewer.
Thanks. So I hope you all got to learn something from the conversation that we had, and if you do, please do not forget to give this video a thumbs up. Now, if you have any questions, any suggestions, I would keep having seasoned data scientists from all over the world. If you want me to make some changes to the format or ask some different questions, feel free to comment down below. Do not forget to subscribe to the channel and help us grow. So I'll see you in the next one.